My name's Chelsea Walsh, and I'm a PhD student in soil science. And I'm going to talk about my research with earthworms. And so you might be saying, why are earthworms important? I know I get that question a lot when I tell people about my research. And one of the big reasons is earthworms are often referred to as ecosystem engineers. And one of the most visible places that this is being seen more recently is in northern hardwood forests, where they're having a dramatic effect on species composition and really having a negative impact on understory plants. But they also have the potential to influence crop growth and influence both carbon, soil organic carbon, and greenhouse gas emissions in agricultural fields. And in terms of this project, they're also important because they are sensitive to changes in soil moisture and temperature, and they're sensitive to changes in management. So both climate change itself and changes we might make to adapt or mitigate can affect earthworms. So far, we've done a survey of earthworm densities across 40 sites, across the different zones. And so far, we are seeing differences between the zones in terms of earthworm density. Everything from zone 6, which is looking at the lowest rainfall region, where we have no earthworms, all the way to the higher rainfall regions, where we're getting up to 160 earthworms per meter. And one of the real questions we're asking here in relation to density is, what is the density threshold? How many earthworms do we need to make the impacts? So many of the experiments that you see looking at earthworm impact on plant growth have a somewhat ridiculous density of earthworms in them, thousands per meter square, that you're just not going to see in an actual field. So we want to look at what is that threshold density and how long do they have to be active during the year. So that's one area of research we're looking at. Another is their effect on soil carbon. And when you think about earthworms and soil carbon, it's complicated. They can increase soil carbon by increasing plant growth, so increasing biomass production. They also stabilize soil carbon in their casts, increasing its residence time in the soil. However, they also physically break up litter in the soil, which makes it more accessible to different microbes who then break it up, mineralize it, put it back into the atmosphere. And they also increase microbial activity through a number of different mechanisms. Another thing we're looking at is interaction with aphids, which is extremely counterintuitive because earthworms stay in the soil and aphids pretty much stay out of the soil. And the mechanism for this is earthworms affect the growth of the crop, which in turn affects aphids. And this is a newer area of research, and we're really excited to maybe see if this might come into play in Northwest fields. This is a map that shows our study sites, and these are the Douglas zones, not the AE zones that Dave's been working on. But we're interested in looking at what are the different factors which are driving earthworm density. Is it soil moisture? Is it the period of time that the soil has a high enough soil moisture? Is it soil texture? Is it management practices such as tillage? And so we're hoping that we might put together possibly something along the lines of earthworm zones, where you might be able to predict by looking at other factors what sort of earthworm density are you going to see. So some areas for future integration and future work. Once again, we'd like to identify those environmental and climatic drivers. So we're hoping to get some input from both the modeling groups and other groups into soil moisture levels throughout the years and potential future soil moisture levels. We also would like to identify, once again, that density and activity threshold for earthworms. We're looking at building up some knowledge about earthworm interactions with the important pest aphids. There's also room for looking at other pests too. They've been known to interact with nematodes directly and indirectly. If a nematode happens to be in front of earthworms, sometimes they eat it. So that can play into things. And then also we'd like to see if we can integrate earthworms into existing crop models, such as crop cyst. And that is it.